Hello students, today in this video go into the IUPAC system in a little more detail. What is it? It's about a few rules that we have to follow for naming the compounds. The first one is the longest chain rule. See, we have to fix the root word. Okay, only when the root word is fixed we can go into the prefix and the suffix. So the first one is the longest chain rule. What does it say? We have to fix the root word based on the longest chain. Now let's take this example. You have 1, 2, 3, 4, 5 carbon atoms. It could be either way. It could be 1, 2, 3, 4 carbon atoms. From here if we start 1, 2, 3, 4 carbon atoms. So 2 roots are giving you 4 carbon atoms. 1 root is giving you 5 carbon atoms. So which is longer? 5. Therefore, the root word would be pent. That is how we fix the root word based on the longest chain. Of course, it is single bonded. Therefore, it would be pentane. Okay? But pent comes because this way it is the longest. Let's see this one. 1, 2, 3, 4. 4 carbon atoms. It should be bute. But there's another way. 1, 2, 3, 4. Again it's 4. Let's take this way. 1, 2, 3, 4, 5. So which is the longest chain? 5. Therefore, that chain is again pentane and not butane. We should not write it straight. Okay, this is wrong. Pentane is the correct one. This is what this longest chain rule means. Okay, next we go to the numbering of the carbon atoms. See, when you go in a train or a bus, you book a ticket, you would always be given a seat number. Without a seat number, would you be just asked to get into this compartment? There would be a lot of fights, isn't it? So like that here also, numbering is very important for the carbon atoms. Let's go to the first one. It says the functional group gets the least number. So the most favorite one is the functional group. Okay, and we have to just look into the compound to see if there is an alcohol or an aldehyde or a carboxylic acid or a double bond or a triple bond. So 5 things we have to look for. When you look at the compound, see for these 5 things. Now let's see this one. In this compound, what is the functional group given here? Alcohol. Okay, first fix the root word. 1, 2, 3, 4, 5. Therefore, the root word is pent. And are there double or triple bonds? No. So, pent. It is pentane. But there is a functional group that is an alcohol. Therefore, E is replaced by pentanol. That's a name. But we should know where this alcohol is present. How do we do that? If we start from this side, what does our rule say? If functional group is present, it has to get the least number. Let's start counting from left to right. This will be carbon atom 1, this will be 2, this is 3, this would be 4. So, the alcohol group is attached to the 4th carbon atom. That is one possibility. The other possibility is to count from right to left. Let's see that. So, this is the first carbon atom, this is the second carbon atom. So, the alcohol group is present in the second carbon atom. Which one is the least number? 2 or 4? 2 is the least number. So, we take it this way and not number it this way. Therefore, this 2-pentanol is the correct one. Or to be very correct, we can also write it as pentanol. Because this alcohol group is present in the second carbon atom. That is what it means. Okay, let's come to this. 1, 2, 3, 4. So there are 4 carbon atoms. So the root word is but. Okay, and a triple bond is there. If it's a single bond, ANE. A double bond, ENE. For a triple bond, it would be YNE. Okay. Where is this triple bond present? If we count from left to right, this would be the first carbon atom, this is the second, and this triple bond starts at the third carbon atom. We should always number it from the carbon atom from which it starts. Okay, this is one way. Let's start from right to left. It starts from the first carbon atom. Okay, so which one is correct? This one is correct. This is not correct. So that means it is 1-butene, or to be very correct, how do we write this? But-1-ine. This is also the correct one. So 1-butene or but-1-ine. Okay. Why? Because this gives the least number to the functional group. So 2 rules over, the longest chain is over, and the functional group gets the least number. Okay. Supposing there is the functional group and the substituent group. So both are in competition. Which one gets the least number? Still, the functional group only gets the least number. So that is the third thing we should remember. If both are present, still the functional group gets the least number. Let's look at this example. Again, let's check the root word. 1, 2, 3, 4, 5 carbon atoms. Pent. If we come like this also, 1, 2, 3, 4, 5. So it is pent only. Okay. So the root word is pent. Okay. Now, look for functional group. Is there any OH or CHO or COOH? Yes, there is an OH. That's the alcohol. So that should get the least number. So we have to count from right to left. So when you start counting, alcohol group comes in the second position. Automatically, there is a methyl group, that is a substituent group, that gets the 4th position. 4th carbon atom it is attached to. Therefore, you would write it as, this is a prefix. The methyl group is a prefix. So it comes before the root word. So 2-methyl. Is it 2? No. This will be 4-methyl because 2, if we are giving for alcohol, automatically the other number that comes, as you number it, whatever number comes here, that goes to the substituent group. So 4-methyl is done. Pentanol. And where is this alcohol group? In the second position. Therefore, pentan 2-ol. So this is the compound, or you may write it as 4-methyl 2-pentanol. Okay, that's over. Let's take another example. Where is the functional group? I said along with the functional group, we also consider double and triple bonds as the suffix. Therefore, let's see the root word first. 1, 2, 3, 4, 5. Therefore, the root word would be pent. That is done. There is a double bond. So that has to be given the least number. So we start counting from left to right, because when you count from left to right, this gets the second position and the chloro group gets the 4th position. When you count from right to left, it would be 1, 2, and it would be in the 3rd position, which is not correct. Least number to the functional group. So 2 is lesser than 3. Therefore, we count from left to right. Okay. So where is this double bond? In the 2nd position. Therefore, pent 2-ene. Suffix is over. Now we go to the prefix. What is the prefix here? Chloro. Cl we'll write it as chloro. And which position is it? It is attached to the fourth carbon atom. Therefore, 4-chloro. Pent 2-ene. This is the name of this compound. If both are present, still the functional group gets the least number. So that is what we are learning about this. Now we'll move on to the next rule. Now we move to the next rule. What does the next rule say? The carbon atom of the aldehyde and carboxylic acid should be included as part of the root word. Many children make a mistake in this. Children, I don't want you all to make that mistake. Don't do that mistake. Okay, because the aldehyde group has a carbon atom. Here, carboxylic acid also has a carbon atom. Okay, but it should be included as part of the root word. What do you mean by that? Now see this, CH3CHO. CHO is an aldehyde. What do children usually do? There's only one carbon atom. So this is methanal. That is what they would name it. But then, what are we supposed to name it as? Two carbon atoms are there. So it is ethanal and not methanal. Okay. So methanal is wrong. But ethanal is correct. Why? Because it has two carbon atoms. We include that also as part of the root word. Now let's take another example. COOH is the carboxylic acid group, right? So we call this as oic acid. How many carbon atoms are there? If we are including this carbon also, then it would be 1, 2 and 3 carbon atoms, and it is not 2. So it is not ethanoic acid. This is wrong. This is wrong. How many carbon atoms are there? 3. What is the root word for that? Prop. Therefore, the correct name is propanoic acid. This is the correct one. So these are some of the mistakes that children make, which we should avoid. Okay. So add that carbon also into your root word. Okay, next. If same halo or alkyl groups are present, any number, you number it as or name them as di, tri, tetra, penta, hexa, etc. How many number is there? Accordingly, you can name it. Now let's take this one. What is the root word here? 1, 2, 3, 4. 4 carbon atoms. Therefore, the root word is bute. Okay. And is there any alcohol, aldehyde, carboxylic acid, double bond, triple bond? No. So then this compound is butane. Alright. Now let's come to the prefix. There is one chloro group here and one chloro group here. So we have to number them. If we write from here also, it is 2 and 3. This being the first carbon atom. This will be the second and this is the third one. So what we do, we write 2, 3. For each of the substituent group, we have to give the number. So 2, 3. How many chloro groups are there? 2 are there. Therefore, dichlorobutane. This is the name. 2, 3, dichlorobutane. So if there are 3, we would write trichloro, tetrachloro, pentachloro, etc. Now let's come to this. How many carbon atoms are there? Only 2. And single bond. Therefore, it would be ethane. That is the root word is eth, single bond, ethane. That's done. Now let's see the bromo groups. 1, 2, 3, 4. There are 4 bromo groups. 2 in the first carbon atom and 2 in the second carbon atom. Now for everything we have to give the location. Okay, it's like, giving seat number to each and every one in your family. Here also we have to give for everyone. So here 1 comma 1. Okay, and in the second position you have 2. How many are there? 1, 2, 3, 4. Therefore tetra bromo ethane. This is the name of this compound. So if there are more than one, if it is the same, then we name it as dichloro, tribromo, dimethyl, trimethyl, and so on. So that's how it goes. Now the next one. If there are different halo groups, that is also possible. What we saw here is same halo groups. See, in this compound you have only chloro group. In this compound you have only bromo group. But what if there is a mixture of chloro and bromo, chloro and iodo? That's also possible. In that case, we slightly change it. Like we have to arrange it in alphabetical order. The least number goes to the first in the alphabetical order. Now we see here, there are 2 halo groups. One is bromo, another one is chloro. Which one do you think will come in the first in the alphabetical order? B, right? So therefore, we can't number it from left to right, because in that case, this will get 2 and this will be in the third position. Instead, we number it from right to left, which means this is in the first position, this carbon atom is in the second, and this carbon atom is the third one. In which case, the bromo group is attached to the second carbon atom, the chloro group is attached to the third carbon atom. And what is the root word here? 1, 2, 3, 4. Therefore, it is butane. Single bond. So, butane. And 2-bromo. So, 2-bromo. Where is the chloro group present? It's attached to the third carbon atom. Therefore, 3-chloro-butane. This is the name. When 2 different alkyl groups are present, it is different. When 2 different halo groups are present, they are arranged in the alphabetical order. Okay, that is done. Now we move to the last part. If 2 different alkyl groups are present, how do you get this? See, alkyl, how do you get? Alkane minus 1 hydrogen is the alkyl group. Now this is called methyl. Okay, this name of this CH3 is methyl. This is ethyl. 2 carbon atom, ethyl. Which is bigger? From the look you can say CH3 is smaller, ethyl C2H5 is bigger. If 2 alkyl groups are present, the smaller one gets the least number, the preference. Therefore, you start counting from left to right and not right to left. Okay? So, in the case of 2 different alkyl groups, the smaller group gets the least number, which means this becomes the first carbon atom, this is the second, and this is the third. Therefore, we write it as, what is the root word here? 1, 2, 3, 4. Therefore, the root word is again butane, single bond. So, butane. And the methyl group is attached to the second carbon atom. Therefore, 2-methyl. All right. And where is the ethyl group attached? To the third carbon atom. Therefore, 3-ethyl butane. Okay. So, these are the different rules that we follow in naming the compounds according to the IUPAC system. Okay. So, the longest chain we saw, giving the least number to the functional group was over. If both are present, still the functional group gets the least number. Then the carbon atom of the aldehyde or the carboxylic acid is also added as part of the root word. And then we come to if there are two similar same halogen groups, okay, either chloro or bromo or iodo or fluoro, or if you have similar methyl group, alkyl group, if they are same, we name them as di, tri, tetra, penta, etc. And then if there are two different halo groups, we name them according to the alphabetical order. And if there are two different alkyl groups, the smaller one gets the least number. So if we keep all this in mind, our naming of IUPAC, in IUPAC names of the compounds will become very easy. Okay, just go through again and again and then get ready to look into the structural formula of the compounds. So having looked at the rules for naming the compounds, let us try some of the compounds. Let us see whether we are able to name the compounds. Okay? Yeah. Now let us look at this compound, following the rules one by one. Okay? So the first one is 1, 2, 3. So there are 3. So the root word would be prop and single bonded. So it will be propane. Okay? And what is there? Along with the main chain, okay, propane, there is also something else. What is that? This is called the methyl group. And where is it present? 1, 2 in the second carbon atom. Therefore, we name it as 2-methyl propane. You got it right? Very good. Now let's go to the next one. Okay. See, there are 2 carbon atoms. So, how would you name it? Eth. So, the root word would be eth and single bond. Therefore, it is ethane. You got that right? Very good. Now, there are 2 bromo groups also. They are prefix, not suffix. And they are present in the first carbon atom and in the second carbon atom. So, we have to give them the position. So, 1, 2 dichloroethane, sorry, dibromo, no, this is Br, therefore dibromoethane. This is methyl group, this is bromo group in the first as well as in the second position. So 1, 2 dibromoethane. Now let's come to this. What is the root word here? 1, 2, 3, 4 carbon atoms. Therefore, it would be bute. Okay. Now, you see something else over there. There is a triple bond. Where is this triple bond? It's, if we come from this side, this is the first carbon atom. And then it starts from the second carbon atom. If we come from right to left also, it is in the second carbon atom. So, either way doesn't matter. So, it would be 2 and triple bond would end with YNE, 2-butene. Or how would we write it very correctly? It would be bute 2 ine, because the triple bond is in that position. Where? In the second carbon atom. Now come to this. Where is this rule here? Aldehyde and carboxylic acid should be included as part of the root word. Now let's come here. COOH. It is a carboxylic acid and there is a carbon atom. So this carbon atom and this carbon atom together make 2 carbon atoms. Therefore, the root word would be eth. And a carboxylic acid ends as OIC. Therefore, ethanoic acid. This is the name of this compound. Okay, let's write it here. Ethanoic acid. Done. So, this is over. Now, we go to the next one. This has again a long one, 1, 2, 3, 4, 5 carbon atoms. Therefore, the root word would be pent. Okay. Now let's look at some functional group present here. Yes, there is one OH group. That is the alcohol group. Therefore, we would write it as pentanol. But where is this present? If we count from this side, it would be in the 4th position. 1, 2, 3, 4. That's too much. We need to give the least number to the functional group. Therefore, we count from right to left where this gets the 2nd position. It is attached to the 2nd carbon atom. Therefore, it is 2-pentanol, or we can also write it as pentan 2-ol. Done. Now we go to this one. 1, 2, 3, 4 carbon atoms. Therefore, but, and this is the double bond. Therefore, but 2-ene. This is the name of the compound. Now there are 2 more to go. Here you see there are 2 methyl groups. 1, 2, 3, 4 is the root word, and there are no double bond, no triple bond, no alcohol, no aldehyde. Therefore, it is butane. Single bond. Okay. But there are 2 alkyl groups in 2 different carbon atoms. Okay. So if we count like this is in the 2nd and this is in the 3rd. Therefore, we write 2,3 dimethyl butane. This is the name of this compound. So when 2 same alkyl groups are present, we just name them as di, tri, etc. Now let's come to the last one. You have an aldehyde. And this aldehyde also has a carbon atom. So when we include that, it becomes 1, 2, 3. Therefore, it would be propan al. Because it's an aldehyde, we end with the word al. Okay, so you got all this right. Well done. Don't forget to like, share and subscribe to this channel. Bye-bye.